4 steps of regression model, regression analysis. This is the population model for the regression analysis, and then step number 1 is the test for statistical significance. The null hypothesis looks like this coefficient of this regression model, they are equal to 0, meaning that b1 0 means there is no effect of x1 on y. So if we change x, nothing happens to y. So that's what this thing means. And then alternative hypothesis is if any of them not equal to 0, then that's our alternative hypothesis. When we see the model is statistically significant, then we go for practical significance. The measure for practical significance is the r-square value. Now typically if we add more terms in the model, the r-square value increases. That's why we use adjusted r-square, which not necessarily increase when we add more model terms. So this is more appropriate to use when you have less or lower sample size. But if our sample size is large, they should be both almost very close to each other. Now, and then when we see practically significant, statistically significant, then we go interpreting the coefficient. What is the meaning of the coefficient? What is the meaning of this regression model? Now next thing we do is the diagnostic test for the regression model. I think for the diagnostic we'll use another video for the diagnostic model. Let's go ahead and run one of the regression model and see what we see. So here is the age and maximum heart rate data that I have collected from 69 people. So I'm going to copy that data and then I'll put it in Minitab, just age and the maximum heart rate. So what I'm trying to see, can we predict the maximum heart rate of an individual by their age? So if we go to stat and regression and then regression, fit regression model, response is the maximum heart rate, continuous predictor is y age, and then just hit OK. So the first thing is the analysis of variance table that tests whether statistically this model is significant or not. Now we see that the age is significant, and meaning that age affect heart rate. So we just know that. So that's the statistical significance of age. Now the practical significance comes from the model summary, from the r-square value or adjusted r-square value. As I have told before, we have 69 data points here. So this is a quite large data set. For this data set, it is typical that the r-square value is close to the adjusted r-square value. Now what is r-square value? R-square is the variation explained in y by the x. So total out of 100% variation, how much it is explained by the age. So S can explain about 83% variation in maximum heart rate, which is quite good for human subject data because I created that data. Now the coefficient, once we see it's practically significant, I think this is quite good data. It's quite it explains the age, explains the maximum heart rate quite well. Now we go for explaining the coefficient. Now the constant is 218, about 219, and age coefficient is minus 0.19. So this is the maximum heart rate equation. Now this is beta 1 minus 0.9819. So we can explain this way: if we increase age by 1, then the heart rate decrease by 0.89919. If we increase age by 10, then heart rate decrease by 9.8, like that. If we increase age by 100, if somebody's age is 100, then their heart rate will decrease by 98. So basically 218 minus 98, about 120, will be the heart rate for a person who is 100 years old. However, you must be very careful. This regression model is only valid in the region where you have the data. So the maximum age I'm seeing here 61, 63. There is not a person here that has 100 years age, so it's only up to 63. So this model only valid up to 63. We shouldn't be extrapolating or interpolating regression models. So it's just whatever area you have collected, the model is valid only in that area. So and for example, 0 age, we didn't really test it for 0 age. For 0 age, or that means some just newborn child will have 219 heart rate. That is a wrong statement to make, because we did not test any newborn child in this example. The minimum age I can see 19. If we go down 18, I think that's the minimum age I see. So this model only varies between 18 and 63, whatever range we collected the data. Even we cannot say anything for age 15, what happened to that person. So when the model is practically significant, you see the p-value less than 0, meaning that age has significant impact on maximum heart rate. Then you go for the practical significance, the r-square value. How much variation in the maximum heart rate can be explained by the variable age? And if you see, that's quite good percentage. 83 is quite good for human subject data. So we see the model is practically significant. Then we go to interpret the coefficient. In the next video, we'll see how to do the diagnostic on regression, whether this thing is valid at all or we're just doing something crazy. We'll see that in the next video.